Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is just a quick tutorial on Docker. So I'm not going to go over the installation of Docker, so for that go to Docker's documentation, install it for your machine. But once you have Docker installed, let's talk about how to use it. So Docker's pretty cool in the sense that what it does, it allows you to run images or Docker containers. And what Docker containers do is they are like a snapshot of a machine or of a state of a computer, and it runs it from that state. But then when you shut that computer down, it's like it never existed, and then when you run it back up, it starts from that state again. Okay, so basically the idea is you make a snapshot of the computer of your application where you want it, and then you can just run it, and you can just run that container on dozens of computers. Doesn't matter what kind of computer, and that's the beauty of it. What makes this different than a virtual machine is that when you have a virtual machine, it's not necessarily a snapshot, it's more like a mini computer on your computer. Okay, because there's a part of the computer operating system called the kernel. And if I remember right, like basically when you're using virtual machines, it copies the computer straight down to the kernel. It's like a virtual computer straight down to its own kernel, which is sort of like the brain or like the heart of what kind of runs everything. And on top of it, you're setting aside different persistent resources. So you have hard drive space that's dedicated to that virtual machine. That virtual machine can manipulate it and change. Well, you can do that to an extent with Docker. A Docker container doesn't necessarily have persistent storage. It's the minute that container shuts off, everything that changed while it was running is gone. And then if you are using a Docker container, I don't think it uses the same kernel. It works on top of whatever machine you have. It just basically kind of runs everything above that, so that the containers are smaller, they're more modular, which makes it, and then they're less resource intensive because you're not running complete duplicate machines. Okay, it's just running sort of a portion of it. And because, again, they're images, think of it like a little, and that's why you have the image of like the whale with the containers on it, on top of the whale, because the idea, it doesn't matter really where you run the machine. You can run it on a Linux machine, a Mac machine, a Windows machine. The containers are self-contained. So once you have Docker installed, you'll have this Docker command, sudo. So I'm gonna have, on Linux here, I have it set up where I had to use sudo to use it, but okay, sudo docker images. This will show me a list of all the Docker images I've downloaded. And that will, okay, so these are different images I have. So for example, this node image is an image of a computer that has Node installed on it. So if I wanted to deploy a Node project, I could just create, and what you can do is you can create images from images, okay? And that's where this becomes really fun, okay? And then this is an image I made, which is a Ubuntu computer that has Deno installed on it. I use it to deploy Deno projects. There's one for Python, Golang, Ruby, PHP. You guys get the idea. Now let's see, let me think of a language I don't have on here. I guess Crystal. So let's say I wanted to go download an image to use for whatever purpose. Okay, what I can do is I can go look up to see if that image exists. Okay, so I'm gonna let this let Google Chrome open up. Okay, it's opening. So I can close some of these other windows. Nah. There we go. Now let's head over to the Docker Hub. So I think it's a hub.docker.com. And you can upload your own containers here. So basically the cool thing is you create your project, then you create an image with your project. So and then you can just upload it here, and then you can just basically pull it to any server you have that you want to deploy this container on. You just run the container. It's pretty nice. So let's search for, let's go to the main part of Docker Hub. Okay, let's search for, let's say, Crystal, like the Crystal programming language. Okay, Crystal Programming Language. Yep, it's just right here. So that's the name of the container. So then I would just copy that name. Or you can click on it to read the documentation, because different containers have different like variables you may want to use when you use them. So you can just kind of like read the docs. I'm not going to worry about that now. I'm just going to assume it's just a machine that has. And then here's the command: docker pull crystal lang. So now I would just do sudo, and then it already has the command there. So I docker pull crystal lang, and then it downloads it. See, 175 megs. So they're not unreasonable in size. So you can have a lot of containers that cover a lot of ground for not too much space. So that's going to do that. Let me just open up another tab. And now let's say I want to use one of these machines. Okay, so let me go back to the list. Let's use the Ubuntu machine. Okay. I can be like sudo docker run. Now, usually if you just run it, it'll just run. Now, if I want to actually go in there and get access to the command line and interact with it, I can give this flag -it, sudo docker run it, Ubuntu. Chapino here. So that's I'll pull an image first. So I downloaded the newer image of Ubuntu because I didn't specify a tag. So once it used latest, so it went to see if the one I have currently is the latest. And now it's starting it, and here I am in the root. And now I'm in the command line of this sort of image of Ubuntu, and I can just take a look at it and go like ls. See, I have all this stuff in there. Let's see if, again, usually these images are pre-stripped down, so you don't have like a lot of different little programs like nano. So let's see if I do nano stuff tags. Yeah, no. Okay, but you can like explore cd opt ls. Okay, nothing in there. cd dev ls. You guys get the point. Okay, and you can just like delete stuff. So I can sit there and let's go cd up. I'm going to rm-r media. So now that media folder is gone. Okay, but now I am going to get rid of this container. I always forget. I think exits the command. Yep. So that kills the container. Let me just make sure that the container is no longer running. So docker sudo docker ps will list whatever's running. Sudo docker ps, and I'm going to add the L8 flag so we can see everything. And it's docker ps-la. And it's exited, so it's not currently running. So if I were to run that container again, okay, okay, here I am again. If I hit ls, see media is back. So literally, again, any changes I make while the container is running don't stick once I rerun the container. The container always starts from the snapshot. So let me exit that one. So that's done downloading Crystal. So that's how you pull new containers. So that's pretty cool. Let me head over here. Let me close this project. This is something else. Oh, I still have a server running. No wonder everything's running a little chuggy. Kill the server over here. Okay, good. And what I want to do is open up my Express space. Okay. And now if I go over here, let me go to one of these projects. I have one that already has a Docker file in it. Yep, right here. So what happens is that, let's say I wanted to deploy this node project, right? What I want to do is I have the node image, but I would like to create a version of the node image that has my application inside of it. So what you do is in your project folder, you would create a Docker file that's spelled like this. Okay, and basically the way this reads is from the node image, and if I didn't have the image downloaded, it would download it when I run this file. Now my server uses, as you see here, my server uses port 3000. And this is another thing to keep in mind. Your application has to be on host 0000, okay? So you have to figure out in your application, whatever backend framework you're using, how to expose yourself to localhost, or not just localhost, but to port 0000, which makes it listen on all ports. It has just something to do with the way that Docker forwards data. So I had like a lot of frustration in the beginning that I couldn't access my application because I didn't know that. I had to figure that out. So now you know. Okay. But basically, back to the Docker file, I'm saying, hey, I want my application listening. So what this does is tells a container that allow port 3000 to escape the container. So people, the outside of the container can listen to port 3000 of the container. Now, this container, I want a working directory of app when you make this container. So basically, we're going to pretend that we're entering this app folder when it creates this container. And I want you to copy the files in my current folder. Okay, in my current folder, so it's going to copy this whole project 2 folder, and I want you to copy it to the working directory. So it copies not the folder, but the content of the folder. So it's going to copy this node modules, Docker file, package.lock, package.json, server.js. It copies all that into that app folder in the container, and then whenever you run the container, it's going to automatically run node server.js. So literally it just begins running the application the minute you run the container. Okay, so if I go into terminal, and I want to build that container, I would be like sudo build, sudo docker build. Has to be in the same folder with, well, it doesn't have to be in the same folder with the Docker file, but that's the easiest way to do it. Sudo docker build, then there's a -t flag, then I put the name of the container. So I'm going to, usually the best thing to do is give it your username first, and then slash whatever you want to call it. So we're going to call this node test1. So sudo docker build -t Alex Merced node test1, and I will click. Pretty sure that's good. So it'll ask me for the thing, tiger cheese. What does it say? Build options path URL. HT path URL. I must have forgot some paths, some variables. See if I can find the previous time I used it. Oh, there we go. Docker, no, that's Docker Compose. Here we go. Let's see what was the difference. Sudo. Oh, I forgot. Did I forget to do sudo? Sudo docker build -t. Alex said node test1. Oh, I forgot the dot. The dot represents that you wanted to get the Docker file in this particular directory. So always don't forget the dot at the end. That means go look for the Docker file in this folder. So I hit enter. And you see first it's just walking through the steps of the commands. And there's a lot more commands. You read the documentation, you can walk through all the different commands you can put in a Docker file. These can be pretty complicated. But that's pretty simple. All I did was copy my node application into the image. And then just say, hey, when you run this container, just run node server.js. Easy peasy. So now I can go over here and I can be like sudo docker run. So I'm going to run the container, and we expose port 3000. So what I want to do is I'm going to say I want port 4000 on my computer. So it's -p, port 4000 on my computer to be connected to port 3000 in the container. So now whenever I go to localhost 4000 on my computer, it's going to go search for localhost 3000 inside the container, which will be running, and which was Alex Merced slash, it was express test 1. I'll check. So let me go back over here, take a look. That was Alex Merced express test. So it's just express test, no 1. So sudo docker run -p. And that's good. And those flags, there's a lot of different flags and a lot of different rules you can make. You can even map what's called the volume. So you can map a directory to the container. So basically that way you a persistent folder on your computer is being used by the container. So if you wanted to save data, you could. So here, it's listening. Good. So now let's head over here and go to like localhost 4000. Localhost 4000. Yeah, see, it's working. See, it says cannot get. That means now I just have to remember what the routes are. Let's see here. What are the routes on that particular project? Oh yeah, this whole login thing. Okay, so I want to go to login. That's supposed to be Alex Cheese. Okay. Login Alex Cheese. Wrote logic. Nope, I threw in an accident random space in there. Okay. Login Alex Cheese. You are logged in. Cool. So it works. The point is that it works. You're able to access the application. And now what you can do is you can use this service here, fly.io. And what this does, it allows you to deploy your applications just by using Docker containers. So essentially what you would just do is just read the documentation here. It's like a few commands. And then you just push up your Docker container. Or you actually push up your Docker file. So what it does is that you create your Docker file. You follow the commands, it will build the image on its servers using that Docker file and just run it. And then, yeah, you have your project deployed. Easy. So it doesn't matter if your project is a Go project or whatever language, you can push it up to fly.io because it's just running in the container. And as long as your container maps the output to a particular port, ta-da! Okay, now one last thing that I'm less experienced with is Docker Compose. So this I'll just explain in concept. What Docker Compose does, it allows you to write Docker Compose files. And Docker Compose files allow you to elaborate on much more complicated Docker projects. So while a Docker file allows you to create like one individual image, a Docker Compose allows you to describe how multiple images work with each other. So you could sit there and say, hey, okay, I want an image of WordPress. I want you to spin that up, but I also want you to create a MySQL image, spin that up, expose the MySQL database on this port, okay, and then basically allow the WordPress to be exposed on this port, and then the WordPress will then go, hit that hit the MySQL database, and then the WordPress will expose so that way people can go to it. But basically, instead of having your entire project in one container, which you could have one container that has MySQL and WordPress. But what you can do is you can have more separations of concern. So that way, they're always sort of unique. It's neat. I haven't used Docker Compose all that much yet, so I'm not going to go through how that looks like. But that's what it is. You have Docker. Docker allows you to run containers. You can create your own images from existing images using Docker files. And then you can create elaborate setups of multiple containers using Docker Compose. And this just makes it, once you create your images, or once you use images that already exist, it becomes really easy to deploy or do whatever you need to do when you need to do it. Okay, you just set up a server and you just run the containers that are applicable. And if you need to save files, you can just set up a volume. That would be in your Docker file. You sit there and just say, hey, this directory is going to be this directory on the container, So then whenever you save anything to that directory in the container, it's really saving it to this folder on your computer. So that way, technically, you have somewhere where you can save stuff between instances of running the image. Now in this case, like this application doesn't hold any data. Any databases it might connect to are external to it. So really, I don't need to worry about volumes. You just run the container and the application's up. And then it'll save it to the database that it connects to. And you can run it on multiple servers and all that good stuff, which is pretty awesome. So Docker is super cool. I will see you guys later. Have a great day and enjoy.